Hello, this is Sareen from Exam Help Web. Today I'll be solving Chemistry Paper 2 AS Level Structured Questions 9701 Variant 2, February-March 2019. Starting with question number 1, nitrogen is the most abundant gas in the Earth's atmosphere and is very unreactive. Part A, state why nitrogen is very unreactive. So nitrogen is relatively unreactive because of its triple bonding. Say that strong end-to-end triple bond. Part B, magnesium and lithium both form nitrides with nitrogen gas. These compounds both contain the N3- ion. Part 1, write an equation for the reaction of magnesium with nitrogen gas to form magnesium nitride. So magnesium reacting with nitrogen gas as a diatomic molecule. Magnesium nitride will have 3 atoms of magnesium and 2 atoms of nitrogen gas. Because the charge carried by Mg, which was +2, will now be the number of atoms of nitrogen, and the charge which N was carrying, and that was -3, that will be the number of magnesium atoms. Part 2, sodium lithium nitride reacts with water according to the following equation. State one observation you would make during this reaction. So solid and liquid, and then aqueous and aqueous. So this solid will dissolve. I should say solid will disappear. Part C1, state the industrial importance of ammonia. So ammonia can give out ammonium compounds which are of good use to plants, so they can be used as fertilizers. Part 2, one method of producing ammonia is by heating ammonium chloride with calcium oxide. Explain why the reaction of ammonium chloride with calcium oxide produces ammonia. Calcium oxide over here, which you see, is more basic in nature than ammonia, which is present in NH4Cl. So it displaces NH3 from NH4Cl, because displacement reaction says that the stronger species will replace the less strong species from its aqueous solution or from its solution. That's why calcium oxide, being the stronger one than NH3, will be replacing NH3 from its solution. So I should write CaO is a stronger base than NH3. That's why it replaces NH3 from NH4Cl. Part D, 3 oxides of nitrogen, nitrogen monoxide, nitrogen dioxide, and N2O can be formed under different conditions. Part 1, complete the table to give the oxidation numbers of nitrogen, nitrogen monoxide, and nitrogen dioxide. So in nitrogen monoxide, oxygen carries an oxidation number of -2, hence nitrogen carries an oxidation number of +2. In nitrogen dioxide, since oxygen is carrying -2, so nitrogen will now be carrying an oxidation number of +4. Part 2, nitrogen dioxide can be formed by different chemical reactions. Write equations for the formation of nitrogen dioxide by the reaction of nitrogen with oxygen. So both gases are reacting with each other and forming nitrogen dioxide. The thermal decomposition of magnesium nitrate. So group 2 nitrates, they decompose to give out group 2 oxides, nitrogen dioxide, and oxygen gas. Hence, magnesium nitrate will decompose to magnesium oxide plus nitrogen dioxide plus oxygen. Last step is to balance the equation. Part 3, molecules of N2O can be formed by the reaction between nitrogen and oxygen. The bond between the N and O atoms is a coordinate bond or a dative covalent bond. The enthalpy change of reaction for this reaction is positive 82 kilojoules per mole. Calculate the bond enthalpy in kilojoules per mole of the N2O dative covalent bond. Use relevant data from the data booklet to answer this question. Okay, so the bonds which are breaking on the left side of the equation are just O to O double bonds, not N to N triple bonds. And new bonds forming on the right are just 2 moles of N2O dative covalent bond, but not 2 moles of N to N triple bond, because these bonds were not broken at first place. So bond breaking is endothermic and bond formation is exothermic. So I should write positive enthalpy for bond breaking for oxygen molecule is 498 kilojoules per mole, and for new bond formation it's negative. And since 2 moles of N2O dative covalent bonds are forming, so 2 multiplied by the value of bond enthalpy of N2O dative covalent bond, which is unknown, that's why I'll assume that it has a value of X, and the total enthalpy change for this reaction is positive 82. Now when you rearrange your formula, you'll get the value of X as 207 kilojoules per mole. And this is positive. Part E, nitrosyl chloride is a reactive gas that is sometimes formed when nitrogen monoxide reacts with chlorine. NaCl is a strong electrophile and readily undergoes an addition reaction with alkenes. Complete the diagram to show the mechanism of the electrophilic addition reaction of NaCl with ethene. Include all necessary charges, lone pairs, and curly arrows, and the structure of the organic intermediate. Okay, so the first step is C to C double bond is electron dense, which will be attracting a partial positively charged nitrogen towards itself. So an arrow pointing towards nitrogen positively charged. So my new intermediate product will be, now the double bond has broken. It forms a new sigma bond, which is bonding NO with this carbon atom. So NO has now been bonded to this carbon atom, while this carbon atom on the right still carries a positive charge. Now the second step is that this partially negatively charged chlorine has now been given a lone pair of electron, because this N2Cl bond breaks heterolytically with chlorine taking away both the electrons which were being shared in this covalent bond, and Cl now has a charge of negative and a lone pair of electrons. So now this lone pair of electron, I'll draw it here. Now this lone pair of electron will be attracted towards the positively charged carbon atom. And your arrowheads needs to be towards carbon positive over here, and over here your arrowheads needs to be pointing towards nitrogen. Question number 2. The elements in group 17 of the periodic table are called the halogens. They form stable compounds with both metals and non-metals. The table gives some data about fluorine, hydrogen chloride, and calcium fluoride. A. Part 1. State what is meant by the term relative formula mass. So this is mass of a molecule. This is definition of relative formula mass, so you need to learn it. As compared to 1 by 12 of an atom carbon 12. Part 2. Fluorine and hydrogen chloride. Fluorine and hydrogen chloride. Part 2. Fluorine and hydrogen chloride are both covalent molecules. Suggest why the boiling point of hydrogen chloride is higher than that of fluorine. So hydrogen chloride has got permanent dipoles, while fluorine gas has just got temporary induced dipoles that are weaker intermolecular forces than that of HCl. So HCl has permanent dipoles and fluorine has induced dipoles, which are weaker than permanent dipoles. Part 3. Explain why calcium fluoride has a very high boiling point. So calcium fluoride, again, calcium is a metal and fluorine is non-metal. This is due to force of attraction between oppositely charged ions, since calcium carries a charge of +2 and fluorine carries a charge of -1. Part 4. Calcium fluoride can be made by the reaction of calcium carbonate with hydrofluoric acid. Write an equation for this reaction, includes state symbols. So acid plus metal carbonate gives you salt plus water plus carbon dioxide. So calcium carbonate acts as a metal carbonate reacting with an acid, hydrofluoric acid. This forms salt, which is calcium fluoride, plus water plus carbon dioxide. Now you need to balance this. So 2 moles of hydrofluoric acid, and you also need to assign them their state symbols. So calcium carbonate is a solid, hydrofluoric acid is in aqueous state, calcium fluoride is also in aqueous state, H2O is in liquid state, and carbon dioxide is in gaseous state. Part B1. Complete the electronic configuration of a chloride ion. Okay, so chlorine gas has got 7 valent electrons, means 7 electrons in its outermost shell. When it becomes chloride ions, means now it has gained 1 electron and is carrying a charge of chlorine negative and has completed its valency, just like noble gases. So it has a complete outermost shell now. So 2s2, 3s2, 3p6. Part 2. When chlorine is passed over hot iron, FeCl3 is formed. However, when iodine is passed over hot iron, the following reaction occurs. State what you would observe during the reaction between iron and iodine. Explain why Fei2 is formed rather than Fei3. So your observation would be iodine is a purple, iodine vapors are purple in color. So purple vapor disappears when iodine finally reacts with iron. So the question says that when chlorine reacts with hot iron, it forms FeCl3, where iron is carrying an oxidation number of -3, means now it is getting reduced from 0 to -3. And when iodine reacts with iron, iodine reduces from 0 to -2. So this shows that iodine is not a strong oxidizing agent, because an oxidizing agent gets reduced in reaction. Chlorine is getting reduced by 1 more unit than iodine is, so this makes iodine of less oxidizing agent but more of reducing agent. So I should write that iodine is not a strong oxidizing agent as compared to chlorine. The more reduced an oxidizing agent gets, the more oxidizing power it has got. So over here, chlorine reduces more than iodine does. So I would say that iodine does not possess a very strong oxidizing power than chlorine does. Part 3. FeI2 is soluble in water. A student carries out a chemical test to confirm that a solution of FeI2 contains aqueous iodide ions. The student adds a single reagent and a precipitate forms. Identify the reagent the student uses. State the color of the precipitate that forms. Okay, so for halide ions test, we have got silver nitrate solution. Iodide ion will give a yellow precipitate in silver nitrate solution. So the reagent is silver nitrate solution, and color of precipitate is yellow. Part 4. Compounds containing iodide ion are often contaminated by bromide ions. Identify a further reagent that the student could use to show that the precipitate formed in Part 3 contain iodide ions. Okay, so there is one more reagent which can be used to test halide ions, and that is ammonia. Whether in concentrated state or aqueous state, it can be used. So I should write ammonia. And iodide ions are insoluble in aqueous ammonia. Part C, HOF is the only known molecule that contains only the elements hydrogen, oxygen, and fluorine. Part 1, draw a dot cross diagram to represent the bonding in a molecule of HOF. Show the outer shell electrons only. So O in the middle. O will be sharing each of its electron out of a lone pair with H and F. So H over here and fluorine here. O will be sharing one of its electrons with H and F both. And fluorine has got 7 valent electrons. Part 2, HOF can be made by the reaction of fluorine with ice at negative 40 degrees Celsius. The reaction is similar to the reaction of chlorine with cold water. Suggest an equation for the reaction of fluorine with ice. So just like chlorine reacts with water and gives HCl and HClO, fluorine will react with water and will give out the similar products, except for that F will be substituting in place of Cl. So it was forming HCl and HClO. Over here it will be forming HF and HFO or HOF. Part 3, HOF is an unstable compound and decomposes to form HF and oxygen. Draw a fully labeled reaction pathway diagram on the axis provided to show the decomposition of HOF into HF and oxygen. Since this is an exothermic reaction, which can be seen right from this sign of the delta H of this reaction, reactants will have higher energy than products due to energy released. And you also need to label that this is of reactant or HOF and this is for HF plus half of oxygen molecule. And you should indicate that this decline or this fall in the enthalpy is negative 139 kilojoules per mole, which is the delta H of this reaction. Part 4, pure HF is a colorless liquid at 273 kelvins. The liquid contains HF molecules that have strong hydrogen bonds between them. Draw a fully labeled diagram to suggest how a hydrogen bond can form between two HF molecules. For hydrogen bonding, you should have a hydrogen atom bonded to either fluorine, nitrogen, or oxygen, due to the fact that these three are strong electronegative atoms. And this same atom, meaning fluorine, nitrogen, or oxygen, should also be having a lone pair of electrons. So for HF, fluorine is one of the three most electronegative elements and is having a lone pair of electrons. So this fluorine will be attracted towards hydrogen of the other H2F molecule. This is hydrogen bonding. For hydrogen bonding, you need this hydrogen to be attached to one of the three electronegative atoms, which means fluorine, nitrogen, or oxygen, and to whatever H is now being bonded, which is fluorine over here, should be having a lone pair of electron. You should also not forget giving partial negative and partial positive charges to each of the atoms in the bond. Part D, interhalogen compounds such as BrCl or IF5 contain two or more different halogen atoms that are covalently bonded. D is an interhalogen compound that contains only chlorine and chlorine. At 0 degrees Celsius and 101325 pascals, 1 decimeter cube of D has a mass of 4.13 grams. Part 1, use the general gas equation to calculate the relative molecular mass, MR, of D. So the formula is PV is equals to nRT, where P is your pressure in pascals, V is your volume in meters cubed, and is number of moles, R has a constant value of 8.314, and temperature should be in kelvins. So our pressure is 101325 multiplied by our volume, which is in decimeter cube. So this needs to be divided by 1000 since 1 meter cube has got 1000 decimeter cubes. This is equal to number of moles is equals to mass divided by molar mass. Since we are given with mass and not directly moles, we can take 4.13 divided by MR, which we have to calculate. This will get multiplied with 8.314 multiplied with, it is at 0 degrees Celsius, means 273 kelvins. And you'll get a value of MR as 92.5. Part 2, use your answer to Part 1 to determine the molecular formula of D. If you were unable to calculate the MR in Part 1, assume that the MR is 130.5. This is not the correct value. Okay, earlier in the question it says that D contains only chlorine and fluorine atoms, so you need to divide 92.5 between chlorine and fluorine atoms. So you will get a formula ClF3, which will have a combined mass of 92.5. Question number 3, P, Q, and R all contain 5 carbon atoms. A student carries out several tests to distinguish between P, Q, and R. Part A, complete the table identifying any observations for the reaction of each reagent with P, Q, and R. If no reaction occurs, write no reaction. Okay, so P over here has got a tertiary alcohol and a nitrile group. Q has a ketone group, and R has got C to C double bond as well as an aldehyde group. Sodium metal, when reacts with alcohol groups, they form hydrogen gas, so effervescence will be seen. With P, sodium will react and give an effervescence. For Q, with sodium metal, for Q and R, there will be no reaction, since sodium metal only reacts with carboxylic acids and alcohols. 2,4-DNPH or 2,4-dinitrophenylhydrazine is a reagent to test for presence of carbonyl compounds. It gives orange precipitate with Q and R, since Q has a ketone group and R has got an aldehyde group. So an orange precipitate forms. Acidified K2CR2O7 is an oxidizing agent which turns green from orange in presence of primary and secondary alcohol groups. For R, on addition of chromate ion, solution turns green because aldehyde oxidizes to carboxylic acid. For Q, there will be no reaction because ketone cannot oxidize further. It already has been oxidized from secondary alcohol, so no reaction. Part B, Q is reduced by NaBH4. Write an equation for the reaction of Q with NaBH4. In your answer, use the symbol to represent NaBH4. Okay, so Q has got a ketone group and reduction of ketone from secondary alcohol. Exactly where carbon to oxygen double bond is located, you should add one hydrogen and one hydroxyl group. So reduction of ketone. So 2 more hydrogen atoms will be added to C5H10O. And to balance my number of hydrogen atoms, we need to add 2 to this side. Part C, R exists as a pair of stereoisomers. Identify the type of stereoisomerism shown by R and draw the structure of the other stereoisomer. So R is basically nothing but an unsaturated carbon structure. There are two types of isomers, one with chiral center, which are optical isomers, which definitely isn't R. So type of isomerism for R is geometrical. In stereoisomer of R is carbon to carbon double bond, and this time we should have two hydrogen atoms on the top. And CHO, which is the aldehyde group, and the ethyl group should be down here. Part D, the infrared spectrum shows corresponds to one of P, Q, or R. Deduce which of the compounds P, Q, or R produces this spectrum. Explain your reasoning. In your answer, identify any relevant absorptions in the infrared spectrum and the bonds that correspond to these absorptions in the region above 1500 per centimeter. So, I see there is a weak peak here at around 2200 to 2300 per centimeters of wave number, as well as at around 2900 to 3000 per centimeter. There is a strong peak from 3300 to 3350 per centimeter. When you match all these peaks and wave numbers with your data booklet page 14, you see that 2200 to 2300, which is this one, there is a nitrile weak peak, which is correct. And those were the values which we got, and they both match. At around 2900 to 3000 centimeter, there is an alkane group present with a weak peak, which again matches to the values which are given in the data booklet. And at last, around 3300 to 3350 per centimeter, there is an hydroxyl group. Hence, this spectrum is of compound P. An explanation to it is that carbon to nitrogen triple bond is present at 2250 per centimeter. And the next bond which causes these peaks is the hydroxyl group at 3100 to 3700 per centimeters. Question number 4. Allyl chloride is an important chemical used in the manufacture of plastics, pharmaceuticals, and pesticides. Part A, give the systematic name of allyl chloride. So let's first draw the structural formula of allyl chloride. Okay, so I'll start numbering my longest carbon chain, which is this one. This is my longest carbon chain. I'll start numbering these carbon atoms from the end, which gives least number to the carbon atom that's bonded to my functional group. Over here, our functional group is the double bond but not chlorine atom. So 1, 2, and 3. Hence, the systematic name of allyl chloride, this allyl chloride, is 3-chloro prop 1 ene. 3-chloro means the chloride ion is attached to the third carbon atom. Prop 1 ene, prop means my longest carbon chain is consisting of 3 carbon atoms, so it's prop. And 1 ene means that double bond between 2 carbon atoms is between the first and second one. Part B, allyl chloride can be produced by many different methods. The most common method is chlorination of propene, which proceeds by a free radical substitution mechanism. Part 1, the initiation step in this reaction is the formation of chlorine radicals from chlorine molecules. State the conditions required to initiate this reaction. So conditions for homolytic fission of chlorine gas is UV light. The propenyl radical is formed in the first propagation step of the reaction. Write an equation to show the formation of propenyl radical in this propagation step. So one chlorine radical which is forming in the first initiation step will now be reacting with our reactant, that is propene, and will be forming one of the products and a radical. So chlorine radical reacting with propene, it will be forming one of the products, which is HCl plus propenyl radical. Part 3. Explain why the free radical substitution reaction gives a low yield of allyl chloride. So free radical substitution reactions are usually uncontrolled. So you cannot really have a hold on the yield of the products of free radical substitution reactions. Part 4. Allyl chloride can also be formed by the following substitution reactions. Suggest the identity of reagent X. So to convert alcohols to halogenoalkanes, PCl3 with heat, PCl5 or SOCl2 can be used. So you can write either of these three. I'll say PCl5 since that is the most common one. Part C. A series of reactions starting from allyl chloride is shown. Part 1. Suggest a reagent that can be used in reaction 1. So reaction 1 is opening of this pi bond and formation of two new sigma bonds. When C to C double bond breaks and two hydroxyl groups attach, which are this one and this one, this means that cold dilute acidified KMNO4 was used. So I should write cold dilute acidified KMNO4. Okay, reaction 2 is turning alcohol to ester. This requires ethanoic acid because ester's first part with COO ester linkage comes from acid, including COO itself, which is this one. So right before the ester linkage, there are two carbon atoms. This means that my carboxylic acid, which was used in reaction 2, was ethanoic acid. Reaction 3 is a nucleophilic substitution reaction where HCN is acting as a nucleophile and Cl is getting substituted by the nitrile group. Part 2. In reaction 2, the organic product of reaction 1 is mixed with concentrated H2SO4 and an organic acid and then heated under reflux. State the role of the concentrated H2SO4. Identify the organic acid used. So the role of concentrated H2SO4, it acts as a catalyst. And the organic acid being used is ethanoic acid. You have to count the number of carbon atoms present before the ester linkage, which is 1 and 2. Since there are two carbon atoms before the ester linkage, this means the acid which was being used in this reaction 2, number 2, is ethanoic acid. Part 3. State the name of the mechanism that occurs in reaction 3. So this is nucleophilic substitution reaction. Part 4. The organic product of reaction 3 is Y, which contains an ester linkage and a nitrile group. Y can be hydrolyzed using excess aqueous H2SO4 to form Z. The molecular formula of Z is C4H8O4. Draw the structure of Z. Okay, so hydrolysis of nitrile group, which is CN, with strong acid forms carboxylic acid. So over here, I'll have, instead of nitrile, I will have carboxylic acid group. And not just that, but dilute H2SO4 with water reverses esterification, meaning it turns these two ester linkages into alcohol groups, and ethanoic acid will now separate from the structure of Y. So now Y will have OH here and OH here, while CH3COOH will separate from Y. So Z now will have COOH and this will have OH. This too will also have OH. Part D. 2-bromo-1-chloropropane is the major product of the reaction of allyl chloride with HBr, hydrogen bromide HBr. Explain why 2-bromo-1-chloropropane is the major product of this reaction. First of all, I'll draw the structural formula of allyl chloride. This is reacting with HBr. On the major product, Br is attaching to the carbon atom, which is already attached to two methyl groups, which is forming a secondary carbocation. While in the minor product, Br is attaching to the carbon atom, which is already attached to only two hydrogen atoms, means this forms a primary carbocation. And you all must know that primary carbocations are less stable as compared to secondary carbocations due to less positive inductive effect of alkyl groups, which are electron donating groups. So you should write that major product has secondary carbocation as intermediate, which is more stable than that of minor product due to more positive inductive effect of alkyl groups. Alright, so this concludes today's paper. Thank you for watching.